Hi, I would like to present a variant of extensional type theory featuring termination and non-confusion. Let's start with the mandatory vector example, so consider the reversal of a vector using an accumulator. When the vector is empty, we return the accumulator, and in the recursive case, we add the head to the accumulator and recurse on the tail. The new accumulator has length successor of m, and the whole expression has length n plus successor of m, while a successor of n plus m was expected. The core issue being that the two natural number expressions are not convertible. They are, however, provably equal. This means that with reflection of equality, they become convertible. This definition is thus accepted in extensional type theory. That's all well and good, but if we were to make a tiny mistake, say forgetting an argument of the recursive call, we would end up with a different type error. We have an arrow type versus a vector type. But if we are in an inconsistent context, these two expressions become convertible in ETT. This is a case of type constructor confusion, which we want to avoid because it usually corresponds to mistakes. So, can we keep the reflection rule while retaining non-confusion and termination? I propose that the answer is yes if we restrict the reflection rule to shape-irrelevant subterms, hence the S for shape-irrelevant in the conclusion of the rule here. This extends the more usual notion of irrelevant subterms which are all identified for conversion. The specific conversion will stem from uses of conversion on relevant terms, which I write with an R subscript. For instance, the congruence rule for vector types will ask that the length indices are convertible as shape-irrelevant subterms. That means we can use reflection for them, as in the ref example before. The theory is then extended with irrelevant binders. For instance, here you have the type of functions taking an irrelevant argument, as evidenced by the I annotation. These are inhabited by functions for which the body can only use the variable x in irrelevant positions. The story is slightly different in the type, which may mention the variable x also in shape-irrelevant positions. I say also because relevant variables may appear in shape-irrelevant positions and shape-irrelevant variables in irrelevant positions, but not the other way around. We still provide a way of constructing relevant values from irrelevant proof of false. This can be useful for inaccessible branches of case analysis, for instance. Now, the way we obtain non-confusion and termination is through an erasure procedure, going from shape-irrelevant reflection type theory, SIRTT, to Martin-Löf type theory, MLTT. Vectors are erased to lists. Functions are erased to functions, unless their argument is irrelevant, in which case we only keep the body. But for x-falso, we have a problem, because P is irrelevant, hence erased. Instead, we erase to MLTT extended with axiom false, and use that axiom to complete the erasure. Finally, we show that conversion of relevant terms is preserved by erasure. We can thus lift non-confusion from MLTT back to SIRTT. For instance, if we take an arrow type and a vector type, as before, they are erased to an arrow type and list type, which are not convertible in MLTT, and thus not in SIRTT either. Similarly, erasure preserves one-step reduction and typing, so that we can lift strong normalization from MLTT back to SIRTT. All of this has been formalized in Coq and is now available on GitHub. Thank you for listening.